بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سنتطرق على أول درس في الرياضة التطبيقية في مادة الاستاتيكا. طبعا احنا عارفين في فرق بين علم الاستاتيكا وعلم الديناميكا. فعلم علم السكون اللي هو علم الاستاتيكا، أما علم الديناميكا هو علم الحركة. وأول درس النهاردة إن شاء الله هيبقى على الاحتكاك. وطبعا نظرا لقيمة الاحتكاك في حياتنا اليومية فدرس مهم جدا جدا اللي هو درس الاحتكاك. Welcome my dear student in our math program for secondary 3. Today we are taking the first lesson in static subject. It's called friction. My dear student, before we are studied the friction, look at general revision. The first, when we have two forces, F1 and F2, what is the resultant of the two forces angle between them is alpha. The resultant of two forces between them angle alpha, its resultant are equals square root f1 square plus f2 square plus 2f1 f2 cosine alpha. f1 and f2 are two forces meeting at a point. R direction, it's their resultant. What is the alpha? Angle between them. My dear student, we were studied in secondary, if you have two forces act at a body, angle between them alpha, what is the resultant? Excellent student. Resultant equals square root f1 square plus f2 square plus 2f1 f2 cosine alpha. f1 f2 are two forces meeting at this point. Alpha angle between the two forces. My dear student, what is the direction? Direction is called tan theta equals what? f2 sin alpha over f1 plus f2 cosine alpha. My dear student, tan theta clear that the inclination of the resultant are about f1. Theta is angle between what? R and f1. Then the direction of R, it's denoted by tan theta. What is the theta? Angle between the resultant and the first force. Remember, my dear student, tan theta equals f2 sin alpha over f1 plus f2 cosine alpha. My dear student, look at special case. The first of special case, my dear student, if we have two forces have the same direction, then we deduce alpha equals 0. Why? Because two forces have the same direction. Then what you deduce? The resultant R equals f1 plus f2, and the resultant R has the same direction of the two forces. Look at in the opposite figure, we have two forces f1 and f2 have the same direction. Then direction of the R or direction of the resultant has the same direction of the two forces. My dear student, second special case, if we have two forces, each direction opposite direction. What you mean? In this case, alpha between two forces equals 180 degrees. Then magnitude of R or magnitude of resultant absolute F1 minus F2. R is direction of the greater force. If F1 more than F2, then direction of R with direction of F1. If F2 more than F1, then direction of R with direction of F2. Look at, my dear student, F1 and F2 in the opposite direction, then R equal absolute F2 minus F1 or F1 minus F2. But third case, if F1 perpendicular on F2, what is the result? Then R equals square root F1 square plus F2 square. This is magnitude of R. What is the theta? Tan theta equals F2 over F1. Then if we have two forces are perpendicular, then the resultant equals square root F1 square plus F2 square. What is the direction of R? Tan theta equal F2 over F1. Look at the fourth case. F1 equals F2 equals F. Then what is the resultant, my dear student? Excellent student. 2F cosine alpha over 2. Why? Because we have two forces equals. It's denoted by F. Then the resultant equals 2F cosine alpha over 2. What is the direction? Excellent student. Theta equals alpha over 2. Remember, my dear student, the fourth case is very important. If we have two forces are equal in magnitude, then R equals to F cosine alpha over 2. Direction of R denoted by theta equals alpha over 2. My dear student, we are translate to another title. It's called Distribution of a Force into Two Components. Distribution of a force into two components. My dear student, look at the force F. We have two forces, F1 and F2. What is the relation between F1 and F2? Look at F inclination by F1 by angle theta 1 and inclination angle theta 2 by on F2. Then F1, my dear student, equals what? We have two components, F1 and F2. These are two components of the force F. What you deduce? F1 equals F sin theta 2 over sin theta 1 plus theta 2. But F2 equals what? Excellent student. F sin theta 1 over sin theta 1 plus theta 2. My dear student, remember, if we have two forces, F1, F2 are components of the force F. Theta 1, angle between the force F and component of the F1. Theta 2, angle between the force F and F2. Then if we resolve or resolution of the force about two components, F1 equals F sin theta 2 over sin theta 1 plus theta 2. But F2 equals F sin theta 1 over sin theta 1 plus theta 2. My dear student, if we have two perpendicular direction, F1, F2 are two components of the F, then F1 perpendicular to F2, F1 equals F cosine theta, but F2 equals what? X and so on, F sine theta. Then two components are perpendicular. The first component F1 equals F cosine theta, but F2 equals F sine theta. Look at the previous example or the previous notes. F1 perpendicular to F2. F1 and F2, two components of F, are perpendicular. My dear student, we are translate to another title. It's called resultant of a set of concurrent forces. What do you mean of concurrent forces, my dear student? More forces are intersect at one point, or more forces act on a body meeting at one point. Look at, we have two axes, x, y axis, x axis, y axis, and F1 act in x axis, F2, F3, F4, F5. We have more forces act on the body. Angle between F2 and X is alpha, between F1 and Y theta. Then the resultant R equals square root x squared plus y squared. Direction tan alpha equals y over x. What you deduce, my dear student? If we have set of coplanar forces act at a body, then after resolution two components in perpendicular direction, x axis, y axis, the resultant or magnitude of R equals square root x squared plus y squared, and its direction denoted by tan alpha equal y over x. Alpha angle or measure angle of inclination R on OX. My dear student, we are translate another title, very important title, is called equilibrium. What do you mean of equilibrium? My dear student, if a body is in equilibrium under action of two forces, F1 and F2, what you deduce? Equal in magnitude and opposite direction. Two bodies act on the body, equal in magnitude, opposite in direction, action of line are on the same straight line. We must say the body in an equilibrium. Then the body is in equilibrium under action of two forces F1, F2. We deduce that F1 equal F2 and opposite in direction, and their lines of action are on the same straight line. My dear student, if we have three forces F1, F2 and F3 act on a body, if the two lines of action of two forces meet at a point, what you deduce? Yes, the third force line must pass through this point. Look at the opposite figure, clear that three forces F1, F2, F3 act on a body. F1 angle between F1 and F2 theta 3, angle between F1, F3 theta 2, angle between F2, F3 theta 1. This is Lam's rule. Lam's rule we were studied in the secondary. F1 over sine theta 1 equals F2 over sine theta 2 equals F3 over sine theta 3. This rule is called Lam's rule. We use this Lam's rule if we have one force and two angles, or two forces and one angle, and we find or we solve the remainder force or the remainder angles. Look at, my dear student, triangle force. What do you mean the triangle force? If we have three forces act in a body in cyclic order AB, F1 AB, F2 BC, F3 CA. What to deduce? Remember, my dear student, AB, this line represent F1 vector, F2 represent BC vector, F3 represent CA vector. Then three forces act on a body in cyclic order. What do you mean in cyclic order? In triangle ABC, AB direction, BC direction, CA direction is called cyclic order. Then we deduce this rule, triangle force rule. It's denoted by F1 over AB equals F2 over BC equals F3 over CA. Now we are translate to friction. My dear student, what's the meaning of friction? Before we define the friction, look at, my dear student, we have two types of surface. The first is called smooth surface, has no friction force at all. As example, in ice mountain, no friction force at all area. Why? Because this is smooth surface. The second type of surface is rough. What do you mean of rough surface? Has friction force appear when the body tends to move. My dear student, we have two types of surface. The first, smooth surface, has no friction force at all. But the second is rough surface. What do you mean of the rough? Has friction force appears when the body tends to move. My dear student, the coefficient of friction of a smooth surface equals 0. But coefficient of friction of rough surface equals real number more than 0. Remember, my dear student, coefficient of friction on smooth surface is vanished or equal 0. But coefficient of friction on rough surface equal real number must be more than 0. Look at another title, reaction force. What do you mean of reaction force? My dear student, the two forces R and V not act on the same body, but one of them, look at, my dear student, the body act on the surface. Then we have force is called reaction force. Its symbol R. Effect, this force, effect of table on the body. My dear student, if you put a body on the table, then the table act on the body by force is called reaction force. But my dear student, look at this is the body. When put the body on the table, the body has a weight. Look at the weight, or B. This is two forces. The first force affects the table on the body. The second is effect of body on the table. We have two types of the two forces. Reaction forces. Reaction force is R, but effect of the body on the table when a body act on the table by weight is the symbol V. But the table act on the body by reaction force, it's a symbol R. Look at, my dear student, this is pressure, its symbol BR, act on the table, while the reaction force R act on the body, and due to third Newton law. What is the Newton's law? Third Newton law, every action has reaction, equal in magnitude and opposite direction. This rule of third Newton law, every action has reaction. What is the action? BR. What is the reaction? R. Equal in magnitude and opposite direction. Then we deduce that R equals BR. Now we are translate to another title, is very important title, static friction force. What is the static friction force? It is hidden force, appears only as trying to move a body on a rough surface. My dear student, this title is new title in static subject. The static friction force, it is a force but hidden. This force appears only when trying to move a body on a rough surface. Look at this body put in the surface, has reaction force and weight. Then third Newton law is every action has reaction equal in magnitude and opposite direction. Then R equals W. R reaction force, W its symbol of weight of the body. Look at, if a force act on the body, it's denoted by V. We deduce that this is static friction force, appears when the body move or about to move. Now we are translate to important remark. The first, my dear student, if we put a smooth body on a smooth horizontal plane, what it does? The body is in equilibrium under action of two forces. The first force is weight, second force is R. Look at the weight of the body, W, normal reaction, force R. If we act on a body by horizontal force B, then in this case, my dear students, the body will not be arrested. Why? Because there is horizontal force B act on the body. Whatever the value of B is small, will not arrest, about to move, then when a force acts on the body, this body will not be arrested, whatever the value of B is small. My dear student, look at limiting static friction force. Its symbol Fs. It is friction force when the magnitude of friction force is its limiting value or maximum. Limiting static friction force, its symbol Fs. This friction force appears when magnitude of friction force is its limiting value or reach to maximum value, at which the body is about to move. Look at the body on the surface, has weight and normal reaction, or this is in equilibrium, but B act on the body. This body is rough, has Fs. What is the Fs? Limiting friction force. My dear student, by the end of the lesson, we know that we have two types of surface. A smooth surface has no friction, rough surface has friction force. And we know what is the meaning of static friction force. This is important lesson of the static subject. My dear student, I'm very happy to spend such time with you. Thank you.